Okay, good morning everybody. Welcome to Tanya Cikgu. Alright, so today we're going to answer any questions that you might have. So let's start off with what we learned from last week. Okay, so we're going to start with mata pelajaran kimia. Okay, so if you have any question, hantarkan soalan melalui laman spmflix.com or you can use Messenger Messenger on Facebook spmflix. Alright, cikgu akan cuba menjawab soalan-soalan dalam masa 2 jam yang ditetapkan. So for the next 2 hours, I'll try and answer any questions that you might have. Okay, so we're going to talk about a little bit what we did last week, the differences between metals and non-metals. Okay, so what's going to happen is you must understand that a metal, you look at your periodic table, everybody in group 1, group 2 and group 3 they will be releasing 1, 2 or 3 electrons. So these are all metals. Logam. Okay. Semua logam selalu membentuk ion positif 1. All metals always form positive 1 ions. For example, if these were all ions, they would form positive 1. This one is positive 2. This one is positive 3. Okay, all metals always form positive ions. Negative non-metals. Non-metals always form negative. For example, 2,5, 2,8,5, 2,6, 2,8,6, 2,7. So they form negative 3, negative 2 and negative 1. Alright, so whenever you want to know whether it's a metal or non-metal, whether it's a positive or negative ion, you look at the metals or non-metals. Okay, so kita cuba satu soalan. Terangkan tindak balas endotermik. Tindak balas endotermik dan tindak balas eksotermik. Okey. Untuk endotermik, haba diserap. Contohnya, apabila kamu ada air, suling dan tambahkan garam, garam biasa. Natrium klorida. Okey. Jika kamu letakkan termometer, suhu akan menurun. Ini disebabkan haba diserap. Sekiranya kamu letak tangan di sini, tangan kamu akan rasa sejuk. Pelajar selalu confuse. Cikgu, jika endotermik dan haba diserap, mengapa suhu boleh menurun? Bukannya suhu meningkat. Bukan. Haba diserap daripada persekitaran dan diserap ke dalam bahan kimia kamu. Maksudnya, bahan kimia NaCl ini menyerap haba daripada air, daripada tabung uji dan memecah menjadi ion natrium, ion klorida. Apabila haba diserap ke dalam bahan kimia ini, air kehilangan haba. Oleh itu, suhu air menurun. Tabung uji kehilangan haba. Oleh itu, suhu tabung uji menurun. Tetapi, bahan kimia ini sendiri mempunyai lebih tenaga. Seumpama, saya memberi duit kepada kamu. Saya kehilangan duit, kamu lebih duit. Haba diserap oleh bahan kimia. Oleh itu, pada asalnya, natrium klorida yang belum larut dalam air tidak banyak tenaga. Tetapi apabila dilarut dalam air, dia serap tenaga daripada sekitaran dan ion natrium dan ion klorida dalam bentuk aqueous lebih tenaga. Tenaga itu datang daripada air, tabung uji. Oleh itu, air dan tabung uji mempunyai suhu yang menurun. Okey, ini ialah tindak balas endotermik. Eksotermik adalah terbalik. Bagi tindak balas eksotermik, contohnya kita tambahkan pepejal natrium hidroksida. Okey, kita tambahkan pepejal natrium hidroksida kepada air suling dan kacau. Suhu sekarang akan meningkat. Ini disebabkan haba dibebaskan. Haba dibebaskan daripada natrium hidroksida. Natrium hidroksida akan pecah dan membebaskan haba kepada air. Oleh itu air merasa panas. Apabila menjadi ion natrium dan ion hidroksida, dia ada kurang tenaga daripada pepejal. So, tenaga bahan kimia ini menurun. Tenaga dia turun disebabkan dia bebaskan tenaga kepada persekitaran. Persekitaran dia merupakan air dan tabung uji. So, itu bezanya endotermik dan eksotermik. Untuk endotermik, disebabkan haba diserap, perubahan tenaga dia ialah positif. Untuk eksotermik, kerana haba dibebaskan, perubahan tenaga ialah negatif. So, itu bezanya tindak balas endotermik dan eksotermik. Can I have the next question? Can you explain sublimation process? Okay. So, sublimation alright. So, untuk bahan yang biasa, okay, for normal matter, what happens is solid turns to liquid, then turns to gas. Okay, solid turns to liquid is melting, liquid to gas is boiling. Gas can turn back to liquid, condensation. Liquid back to solid is freezing. However, a solid can directly change to gas and a gas can directly change to solid. This is called sublimation. Sublimation doesn't happen to all particles. Sublimation happens to only certain particles because the temperature for sublimation is lower than the temperature for turning to liquid. It skips one step and immediately becomes a gas or immediately becomes a solid. Okay, this is for example carbon dioxide. Carbon dioxide, when it's solid, the carbon dioxide particles are close together. Okay, so this is called dry ice. It looks and feels like ice, but it's much, much colder. It doesn't melt. So what happens is when the temperature increases a little bit, the solid immediately evaporates out and it doesn't become liquid. It immediately becomes carbon dioxide gas in the air. So that is sublimation. Okay, so the same concept happens where it receives energy from the surroundings and it starts to vibrate. The only difference is it doesn't need to vibrate until it changes to liquid. It immediately breaks the attractive forces and immediately turns into a gas. Okay, so that is called sublimation. All right, are there any more questions? Okay. From Gibson Lee, an oxide of an element X has the empirical formula of X2O3. 2.24 of element X reacts completely with 0.96 grams of oxygen. What is the relative atomic mass of X? Oh, okay. So you still do the same thing. Every time it's a question on empirical formula, you always do the same thing. You always do the table. Okay, so we put mass here. Find amount of moles. Okay, so we do not know the relative atomic mass of X. So we just put X. But it's mass over molar mass. Molar mass of oxygen is 16. It's given in the question. So 0.96 divided by 16, 0.06. Okay, this one we don't know how much is it, but we do know the ratio is 2 to 3. Okay, so 0.06 to 3 is the same as whatever answer you get here equals to x. All right. So let's see. 3 divided 0.06 is 50. Okay, so hold on. 3 divide 0.06 equals to 50. Okay, so which means that 0.06 times 50 equals to 3, right? That means whatever answer you had here times 50, 2.24 over x times 50 equals to 2. Get it? Okay, you can do cross multiplication. I'm just trying to explain to you that the ratio of this to this is the same. Okay, if here you times 50 to get 3, over here you had to times 50 to get 2. Get it? All right, so this gives you x 2.24 equals to, x equals to 2.24 times 50 over 2. 2.24 times 50 over 2. So you get 56. So the relative atomic mass is 56. I mean, you don't have to do it this way. You can also do cross multiplication where 2.26 over x equals to 2 times 3. You can do that too. But I'm just explaining to you how 50 is the common factor on how we got from this result 0.06 to 3. Usually what we do is we just divide the smallest number. Okay? So your answer is, it's a little bit, let me write it properly for you. 2.24 over x times 50 equals to 2. Therefore, x equals to 2.24 times 50 over 2 equals to 56. So, x is iron. All right. How do we know the ratio is 2 to 3? Because it's already given in the question. The question already gives you Fe2O3. So we already know this ratio is 2 to 3. Okay? Can you understand? So the answer is B. Oh, sorry. I didn't know it was MCQ. B. Okay, can I have a next question? Oh, Carta Raja Bab 2 tingkatan 5. Okay, sebatian karbon. Is it? Okay, sebatian karbon. Alright, so is bab 2 sebatian karbon or is it redox? I think it's sebatian karbon. Okay, so Aiman, you want sebatian karbon, is it? Okay, if it's not, just send another question to say which topic it is, okay? So, sebatian karbon ialah alkana, alkina, alcohol, acid carboxylic, dan ester. Okay? Alkana, CnH2n plus 2, alkena CnH2n, alcohol CnH2n plus 1 OH, acid carboxylic CnH2n plus 1 COOH. Okay, ester, biasanya tak tanyalah, but if you want to know, it is CnH2n plus 1 COO CmH2n plus 1. Okay, so alkana ke alkena, alkena ke alcohol, alcohol ke carboxylic acid. We talk about this one way dulu. Okay, alkana ke alkena kamu tak belajar. It's called cracking, but you don't learn in SPM. Basically, kita ambil alkana dan lalukan di antara porselin, kepingan porselin panas. Tapi dalam SPM tak adalah, tak apa. Kamu hanya belajar alkena jadi alkana. Okay, so alkena jadi alkana ialah penghidrogenan. Okay, penghidrogenan menggunakan suhu 180 sehingga 200 darjah Celsius dan menggunakan katalis nikel atau platinum. Okay, so itu ialah penghidrogenan, penambahan hidrogen. Alkena ke alkohol, kita gunakan penghidratan. Penghidratan menggunakan air, tapi air bukan air lagi lah, dia dalam bentuk steam sebab dalam suhu 300 darjah Celsius, 60 atmosfer dan juga dalam kehadiran asid fosforik. Okey. Kemudian alkohol ke asid karboksilik kita menggunakan pengoksidaan. Pengoksidaan ini bukan gunakan gas oksigen dengan pembakaran, tapi menggunakan ejen pengoksidaan iaitu kalium manganat 6 berasid, yang berasid. Okey. Kemudian alkohol boleh tukar balik menjadi alkin dengan penghidratan. Penghidratan ialah pengeluaran air daripada alkohol. Penghidratan menggunakan kepingan porselin panas. Atau kita boleh gunakan aluminium oksida. Okey. Akhirnya alkohol dan asid karboksilik bergabung menjadi ester. Ini dalam proses pengesteran. Okey. Dalam proses pengesteran kita menggunakan mangkin asid sulfurik pekat. Okay. Alkena merupakan bahan yang boleh menjalankan banyak tindak balas yang lain. Alkena pun boleh menjalankan proses pengoksidaan, penghalogenan dan juga pempolimeran. Okey, ini disebabkan alkena, alkena mempunyai ikatan double. So dia banyak boleh bertindak balas. Pengoksidaan boleh menggunakan kalium manganat 7 berasid atau boleh menggunakan kalium dikromat 6 berasid. Okey. Bezanya ialah kamu boleh menghasilkan diol. Maksudnya ialah daripada satu hidroksil dia jadi 2 hidroksil. Diol. Okey, sekiranya inilah etina, dia jadi etin 1,2 diol. Penghalogenan ialah penambahan halogen. Contohnya klorin, bromin, iodin. Okey. So contohnya sekiranya penghalogenan dengan bromin, di sini kita menjadi 1,2 dibromo etana. Okey. Akhirnya pempolimeran. Pempolimeran menjadi plastik, menjadi polimer. So jika kamu ada etina, dia jadi polyetina. Di mana dia membentuk satu rantaian karbon yang sangat panjang. It will just go on and on and on. Untuk lebih 1000 karbon, okay, dia akan bersambung dan ini dipanggilkan polyetina. Sekiranya guna propin, polipropina, tapi dia biasanya dipanggil plastik lah. So ini sebagai rumusan untuk bab 2 tingkatan 5. Okay. Next question please. Okay, so do I have a next question? No. Alright, so let's talk about bagaimana membentuk sebatian ionik. Ionic compounds. Okay, so ionic compounds must be made from metal, logam, contohnya natrium, and non-metal, bukan logam. Okay, so yang logam selalunya membebaskan elektron, yang bukan logam menerima elektron. Daripada 281 dia menjadi ion natrium 28. Daripada 287 dia menjadi ion klorida 288. Ion-ion ini akan mempunyai daya tarikan elektrostatik yang menyebabkan dia berdekatan. Okay, so if you want to draw to 8. Okay, and then the chlorine 2, 8, from 287 become 288. So make sure you draw the last one differently. Oh. Okay, this one should be a different color. Okay, draw cross, okay? This one I use dot, that one side I use cross. So 2, 8, 8. But you draw 7 first. The 8th one is the one that's different. Okay? So it's negative. Right, so that's how you draw ionic. Okay, so Faiz banyak skip kelas kimia ketika tingkatan 4. Bab-bab tertentu. Okay, so yes, you can still catch up. Okay, perhatikan kepada bab-bab yang cikgu sedang ajar sekarang, iaitu tindak balas kimia, ikatan ionik, ikatan kovalent. Sebenarnya bab-bab tingkatan 4 bukan susah sangat. Okay, sekiranya kamu nak belajar sekarang bab-bab garam dan asid, kamu tunggu sekejap, kamu belajar balik jadual berkala dan ikatan kimia, dan juga tentang atom, ion, elektron, proton, neutron. Okay, kamu juga boleh gunakan video-video yang cikgu sudah sediakan. Alright, video-video ada bab-bab tingkatan 4, so you can look through that, dan masih ada masa. Okay, masih ada masa. Alright, so Don't worry so much. Okay, poor thing, help me. Alright, so untuk Faiz, you can still catch up, masih ada masa. Mulakan dengan bab yang paling senang. Bab-bab tingkatan 4 memangnya senang. Mula dengan jada berkala dan ikatan kimia. Okay. Alright, so ini merupakan sebatian ionik. Okay, sebatian ionik. So sebatian ionik sama untuk semua logam dan bukan logam yang kamu nak binakan. So for example, if I do magnesium or aluminium, dengan oksigen. Okay, so aluminium 283. So sebab dia 283, ini ialah logam. Okay, oksigen 26, ini 6, ini bukan logam. Alright, so aluminium membebaskan 3 elektron daripada 283 menjadi 28. Oksigen menerima 2 elektron daripada aluminium daripada 26 menjadi 28. Okey, tapi kamu mesti pastikan aluminium ialah 3 positif, oksida ialah 2 negatif. Dia bukan satu ion. Okey, so aluminium 3 positif, oksida 2 negatif. 3 ini pergi ke sini, 2 ini pergi ke sini. So Al2O3. So kita perlukan 2 ion aluminium, 3 ion oksida. Okey, so ion aluminium ini bercharge 3 positif. So kamu kena lukis 2 lah. Okey, untuk yang negatif kena lukis 3 sebab it's Al2O3. Okay, so oxygen you have to draw 3. Now when you draw oxygen, be careful. 2, 6 is the oxygen one. 1, 2, 3, 4, 5, 6. The other 2 come from aluminium. 7, 8. You see that? This is 2 negative. Okay, so saya tak mahu lukis 3 lah. So ini kamu kena lukis 3. Yang untuk yang ni, kamu kena lukiskan 3. Alright, so ini ialah cara beza untuk melukis aluminium oksida. Okay, next question. Atomic radius is the same as atomic size. Yeah, it's the same. Atomic radius means, say this sodium, 281. Radius means from here to here lah. Size just means here to here. But they don't ask you compare atomic radius and atomic size. No, it's asking who is bigger, who is smaller. It's the same thing. Okay? Alright. So, is there a next question? So atomic radius, atomic size, they're asking the same thing. It's basically they're asking you who is bigger, who is smaller. So if you have your periodic table, okay, if you have your periodic table, then lithium, sodium, potassium, right? Then they ask you who has a bigger atomic size or atomic radius, potassium or sodium. Then you just say, potassium or sodium. So potassium is bigger lah. Because potassium is 2881. Sodium is only 281. Okay, so potassium is 2881 and sodium is only 281. So potassium has a larger atomic size as well as a larger atomic radius. Okay. However, when you go across a period of the same period, it gets smaller. So for example, sodium is 281, chlorine is 287. It looks like 7 should be bigger than 1, right? But it's not. 7 is smaller. The reason is because, okay, so when we compare 281 and 287, okay, so this is the nucleus. The nucleus is positive. Okay, so, oh wow, that's so small. Okay, so 2, 8, 1. There are 3 shells, and then chlorine, the nucleus is also positive, but chlorine is 2, 8, 7. So it should be the same size. But the nucleus of sodium is positive 11. The nucleus of chlorine is positive 17. So positive 17 pulls in the electrons stronger than positive 1. So therefore, you go this way, the size of the atom is smaller. Okay? Diagram 13 shows the formation of compound X when compound S reacts with compound. Is there any way I can see a larger version of this question? Okay, let me try and do this. Compound S is, sorry, I really can't see. Can you all send it to me or something? Or take a snapshot of it? I really can't see the question. Okay. Is there another question? Not yet. Okay. So I'll continue with something. So Hanan, we'll come back to your question. Kejap because it's too small. Cikgu tak nampak. Okay. So what were we talking about just now? Okay. So atomic radius, right? So as you go across, okay, if you go from up to down, okay, the size as well as the atomic radius becomes bigger. If you go from left to right, the size and the atomic radius becomes smaller because the attractive forces, it's 3 shells, okay? Like for example, period 3, sodium 3 shells. 1, 2, 3. Chlorine also 3 shells. 1, 2, 3. The difference is the size is smaller because positive 17, the nucleus has more protons, so there is more attractive forces pulling in the same thing. Okay, so that's the difference between the sizes across the period and from up and down the same group. Okay. Okay, so let's try and look at this question. Obviously has something to do with esters. Okay, so again, how do we name esters? So esters are carboxylic acid, okay, acid carboxylic combined together with alcohol. Okay, so your CnH2n plus 1 COOH and your CnH2n plus 1 OH. Okay, so for acid, you always take this long part and put in the first part of your ester. Okay, and then this second part here, is the second part of your ester. So that's how you write the equation for ester. Okay, the formula for ester. So For example, if it is ethanoic acid, okay, acid ethanoic together with butanol. Okay, so acid ethanoic is CH3COOH. Butanol is C4H9OH. So how do we draw this? So to draw this, what we do is we take the top part CH3, COO. Okay, we take the first part. Okay, then the alcohol part is always at the back. C4H9. Okay, so this part here, this COO part here, this part here, where we see this carbon, this part belongs to an acid. Okay. Now I can see the question bigger. Okay, so the question from Hanan. Compound S is C2H5OH. Okay, and compound T, so C2H5OH, you need to know what it is lah. So this is an alcohol lah, ethanol. Okay, compound T is C2H5COH. So this is ethanoic acid. Okay, how do you know this ethanoic acid? Because there's 3 carbons. 1, 2, 3. And this is ethanol, you know, because there's 2 carbons, 1, 2. Okay, so reflux is how you do esterification. Okay, so compound V, you take the 2 combined together. But you start from the T. You start from the acid, C2H5COO. So C2H5 C2H5COO, this one is propanoic acid. What am I saying? There's 3 carbons. 1, 2, 3. 3 carbons. Okay, 1, 2, 3 is propanoic acid. Okay, so C2H5COO. Instead of H, you just put COO. So here you got 1, 2, 3. So this is propanoic acid. So if it's from the propanoic acid, you put the name propanoate. The acid part becomes the name at the back, propanoate. Okay, so the front part, C2H5. This part, C2H5. C2H5. Okay, so this part has 2 carbons, 1, 2. So this part comes from the alcohol, ethanol. So it gives the name ethyl. So the answer is ethyl propanoate. A and B, and your answer is B. Okay, because B is the one that looks like this. Because the C, the one with the COO is the 3rd carbon, 1, 2, 3. So it has to be COO, this part here. The one with the double bond, this part comes from the acid. So your propanoic acid is the one with 3 carbons here. Okay, can? All right. I think sometimes you get a little bit confused about how to do the esters. Okay, I'll give you another example. Okay, let's say if it's, like this. Okay, and like this. Okay, now, how about you take a minute and try and name the two molecules, okay? So the two esters that I drew on the screen, can you try and name the two esters? Okay? Could you get it? Okay, so now this first one, always look for the carbon that has the double bond O. So this part going this way is the acid. 1, 2, 3, 4. 4 carbons means it came from butanoic acid. So the name is butanoate. Okay, this part came from the alcohol. There's only 1 carbon. So it's from methanol. The alcohol that only has 1 carbon is methanol. So the name of this ester is methyl. Methyl butanoate. Methyl comes from methanol. Butanoate comes from butanoic acid. Okay? Alright, how you do this one? Okay, so again, a lot of students will get it confused and start from here. Oh, here, this way. No, it's not like that. You look for this carbon. Okay, so this part is the acid. 1, 2, 3. This part is the acid. Can you see it's the other way around? C2H5COOH. It's this way. So this part is the acid. 1, 2, 3 carbon is propanoic acid. So propanoic acid is propanoate. Okay? This part, 1, 2 carbons, ethanol. So it's ethyl. So the name of this molecule is ethyl propanoate. Okay? So can you see? This, it's flipped. So you can't just say, I always come from the left. No, it doesn't work that way. You have to look at where the carbon is, which is connected to the double bond to oxygen. Okay? All right? Okay, so you look at the carbon that has the double bond to the oxygen, the carbon that has the double bond to the oxygen. Okay? So if we're done, we can look at the next question. From Shaza, can you briefly explain which important points to know about the salt and water energy? What do you mean, salt and water energy? Do you mean about just now that one, the... Oh, okay, okay. Is it just now the endothermic, that one? Okay, okay. So the endothermic reaction, is it? Shaza, I hope I'm getting your question correct. So salt and water, you meant as in this one, right? The first test tube I did. Okay, so this is water. You dissolve the salt. Okay, there are not many endothermic reactions. Okay, mostly everything we learn is exothermic. Okay, haba pembakaran, heat of combustion, heat of neutralization, heat of displacement. penyesaran, okay, and heat of precipitation. Okay, haba pemendakan. All of this that we learn to count are all exothermic because heat is released to the surroundings and therefore the energy change is negative. Okay, so the surroundings always suhu meningkat. Okay, temperature increases. The endothermic is always the other way around, where you need to absorb more heat. You need to absorb more heat for a reaction to occur. So for example, if I take sodium chloride is solid, okay? In order for it to dissolve in water, it needs to absorb heat. It absorbs heat from the water. It is surrounded. I am putting the sodium chloride in a beaker of water. Where else can it absorb water? Where else can it absorb heat other than the water? So the sodium absorbs heat from the water, the chloride absorbs heat from the water. When it becomes sodium ion and chloride ion in the water, it has now more energy. So it's freely moving. Okay? But if you take a thermometer and you stir and you measure, you will see the temperature went down. Okay, the temperature went down. And if you touch it with your hand, you will see that it's cold. This is called endothermic. Heat is absorbed from the surroundings. Okay, heat is absorbed from the surroundings. And who is the surrounding? The surrounding is the test tube, the water, and your hand. Okay, so that's why the test tube and your water and your hand feels cold. Okay, so heat is absorbed to break the bonds. So now you started out with sodium chloride solid. It absorb energy. Now it's sodium ion and chloride ion aqueous. They have more energy because they have absorbed energy. Because they absorb energy is positive. Okay? So I hope this answers your question. What's important? Important is just to know the heat absorbed is more than the heat release. The reactant has less energy. The product has more energy because the reactant absorbs energy from the surroundings to form the product. That's all you need to know. Okay? And this reaction is exothermic. All right? Okay, can I have the next question, please? Okay. Oxidation and reduction based on electron transfer. Okay, so oxidation is release electron. Reduction is gain electron. Okay? There are certain chemicals that love to release electron. For example, iodide ion. Okay, so electrons always go this way. Okay, electrons always go this way. The one that release electron is oxidation. The one that gain electron is reduction. Some chemicals just love to release electron. Example, iodide ion. Where can you find iodide ion? In potassium iodide. Other examples, iron 2. Iron 2 loves to release electron to become iron 3. Where can you find iron 2 ion? In iron 2 sulfate. Okay? The one that releases electron undergoes oxidation. If it undergoes oxidation, it is called the reducing agent. Okay? The one that undergoes reduction gains electron. If it undergoes reduction, it is called the oxidizing agent. We have some chemicals that love to receive electrons. Example, chlorine. Chlorine water receives electron to become chloride. Okay? Acidified potassium manganate 7. Okay, it loves to receive electron. All right, who else? Acidified potassium dichromate 6. Okay, so these few chemicals, they love to receive electrons. They are professional oxidizing agents and they also change color. Potassium manganate is purple to colorless. Potassium dichromate is orange to green. Okay, can? Alright, so you can choose any one of this to react with any one of this. Okay, any one of the oxidizing agents can react with any of the reducing agents. Alright, so there are a few ways you can do electron transfer. One way is just use a test tube. Okay, so you can just put potassium iodide inside here, chlorine here, right? Not? So iodide loves to give away electron, so it gives its electron. Chlorine loves to take electron, so it's a win-win solution. So what you can do is you can also take these two chemicals and separate them into a U-tube. Here you put a carbon electrode, here you put another carbon electrode, put a galvanometer, okay, so here put sulfuric acid. So over here, you put chlorine water, over here you put potassium iodide. So you already know iodide inside the potassium iodide is the one that's going to release electron. So this is also called electron transfer. Okay, so you can basically change it to any chemical you want. If you don't want to use chlorine, you can use acidified potassium manganate 7. Same concept here. You don't want to use chlorine here, you use acidified potassium manganate 7. The same thing will happen. Okay, you don't want to use potassium iodide here, you use iron 2 sulfate. The same thing will happen. Iron 2 will release the electron. Instead of using potassium sulfate, potassium iodide, you use iron 2 sulfate. Okay, instead of using potassium manganate here, you can use potassium dichromate. So basically it's just somebody release electron, somebody receive electron. That's called electron transfer. But it doesn't just have to be this. It can also happen in electrolysis. Electrolysis is also electron transfer. Okay? For example, if you have an electrolytic cell, okay, and you put carbon electrodes, for example. Okay, we give a simple electrolysis. Electrolysis of diluted sulfuric acid. Okay, so inside here you got hydrogen, you got hydroxide ion. That's going to be discharged. So hydroxide ions discharge at the anode, hydrogen ion discharge at the cathode. Okay, so this is oxidation. This happens at the anode. The electron transfers. It releases the 4 electrons to form oxygen gas. The electron transfer from here to here. So this side is oxidation. Anode is oxidation. Okay? Over here, who is discharged? Hydrogen ion. Okay? This side receives electron. This is reduction. This is also known as oxidation and reduction based on electron transfer. I mean, if the question is asking you about, electrolysis, it's also oxidation and reduction because electron is being transferred. Okay. Another simple example is the simple cell. You put magnesium with copper. And here you put copper sulfate solution. Okay, please don't get confused. This one is not a simple, it's not electrolysis. This one is simple cell. There's a voltmeter. All right, so magnesium being more reactive, magnesium is the one that releases electron. Okay, magnesium releases electron and the electron comes here. So magnesium now is the anode. Here's the cathode. Magnesium is still oxidation. Anode is still oxidation. This is oxidation. And reduction is still at the cathode. Okay, this is also known as electron transfer for redox. There is still oxidation, there is still reduction. Okay, so there are not only these three, there are many times of ways that oxidation and reduction can be transferred of electron, as long as somebody is giving out electron, somebody is receiving electron. Okay, all right, is there a next question? From Atika. Cikgu boleh explain tentang pembentukan ikatan antara molekul. Bab termokimia. Pembentukan ikatan. Oh, okay. I'm not sure. Ikatan antara atom, is it? Is that what we're talking about, Atika? Ikatan antara atom dalam bab termokimia. Okay, nevermind. I teach you about susunan hidrogen dan carbon dalam redox. Okay, so we talk about redox first. So kita ada dua siri. Okay, dalam SPM kita belajar dua siri. Siri elektrokimia. Okay. So helium, yttrium, calcium, magnesium, aluminium, zinc, iron, stannum, plumbum, hydrogen, cuprum, argentum. Okey. Lagi ada satu, siri kereaktifan. Sebenarnya siri elektrokimia dan siri kereaktifan sama saja. Bezanya ialah, okey, we start. Yang helium Natrium, kalsium, magnesiumnya semua sama. Aluminium pun sama. Bezanya sini kita tambah satu karbon. So sini sekarang ada karbon. Okey. Dan lepas karbon ada hidrogen. Antara aluminium dan zinc ada karbon, antara zinc dan ferrum ada hidrogen. Okey? Lepas tu yang lain lebih kurang sama. Tapi ada kala kita nampak ada mercury lah, ada platinum and so on. Okay, tak penting lah. Yang penting ialah biasanya kita guna siri elektrokimia untuk menentukan siapa bebas elektron. So, semakin ke atas, semakin senang bebas elektron. Oleh itu, hidrogen di sini. Disebabkan hidrogen di sini, cuprum dan argentum, copper and silver, tidak boleh tindak balas dengan asid. Dia tidak boleh bertindak balas dengan asid kerana hidrogen lebih reaktif. Tetapi plumbum, stannum, ferrum semuanya boleh tindak balas dengan asid. Walaupun perlahan dia masih boleh tindak balas dengan asid. Okey. Yang ini kita biasanya gunakan semasa dia dalam bentuk aqueous. Okey, larutan aqueous. Maksudnya kita letak magnesium dengan zinc. Siapa bebas elektron? Yang atas. So, magnesium bebas elektron. Di sini, zinc menjadi terminal untuk terima elektron. So, biasanya apabila kita bincang tentang siri elektrokimia, kita bincang tentang reaksinya di dalam larutan aqueous. Siapa bebas elektron, siapa terima elektron. Yang ini yang ada karbon dan hidrogen, beza sikit sebab kita bincang tentang siapa boleh dapat oksigen dulu. Semakin ke atas, semakin reaktif terhadap oksigen. Okey, maksudnya sekiranya saya meletakkan di dalam satu tabung yang ada helium chloride dan dia boleh bebaskan gas oksigen. Okey, dan saya panaskan di sini. Saya letak, contohnya saya letak magnesium, zinc dan cuprum. Okey, saya letak magnesium, zinc, cuprum. Okey, dan saya panaskan. Ketiga-tiga ini dipanaskan. Okey, apa berlaku ialah magnesium akan kuat, zinc sedikit, cuprum hanya akan membara. So, maksudnya ialah magnesium paling reaktif terhadap oksigen, zinc lebih reaktif daripada cuprum tapi kurang reaktif daripada magnesium, cuprum paling tak reaktif terhadap oksigen. Okey, kita boleh gunakan cara yang sama untuk tindak balas karbon kepada oksigen. So, karbon lebih suka oksigen berbanding dengan zinc, tetapi kurang suka oksigen berbanding dengan magnesium. Oleh itu, sekiranya saya letakkan dalam mangkuk pija, saya letak magnesium, oksida dan karbon dan saya panaskan. Magnesium lebih suka oksigen. Karbon kurang reaktif. Tiada tindak balas berlaku. Tetapi sekiranya saya gunakan yang kurang daripada karbon, contohnya zinc oksida, ferrum oksida dan seterusnya, atau saya gunakan kuprum oksida dengan karbon. Siapa yang lebih reaktif? Okey. Karbon lebih reaktif. So sekiranya dengan kuprum, karbon boleh mencuri oksigen kuprum menjadi kuprum dan karbon dioksida. Okey. So dengan cara ini kita kata bahawa karbon lebih reaktif terhadap oksigen berbanding dengan zinc atau berbanding dengan kuprum atau berbanding dengan bawah. Tetapi mengapa hidrogen ada dua tempat yang berbeza? Satu di atas, satu di bawah. Kenapa? Okay. So, yang ini, hidrogen ini untuk asid. Okay. Kuprum dan argentum tidak boleh bertindak balas dengan asid. Tetapi plumbum, stannum, ferrum boleh tindak balas dengan asid. Walaupun perlahan. Di sini beza. Sekiranya saya mengambil tabung pembakaran, saya melalukan gas hidrogen. Okey. Dan sini saya letak iron oksida sini. Ferrum oksida. Dan saya panaskan. Okey. Siapa lebih suka oksigen? Siapa lebih reaktif terhadap oksigen? Hidrogen atau ferrum? So, hidrogen lebih reaktif. So, hidrogen akan curi oksigen daripada ferrum. Okey. So, dia boleh menurunkan Fe2O3 menjadi Fe. Okey. Ini mengalami penurunan. Hidrogen mencuri oksigen dia. Sekiranya saya melihat kepada siri elektrokimia, hidrogen di sini, hidrogen kurang reaktif daripada ferrum. Hidrogen tak boleh curi oksigen ferrum. So, salah. So, oleh itu, kita tak boleh guna siri elektrokimia untuk tindak balas pembakaran atau reaktiviti terhadap oksigen. So, itu bezanya siri elektrokimia dengan siri siri kereaktifan. Okay. I'm not sure about the question ikatan antara molekul. Can you word it again? Beri saya contoh, cikgu mungkin boleh jawab. Okay. Can I have a next question? Tafsirkan kualitatif dengan kuantitatif persamaan kimia. Can you give me an example? Contoh, sebab sekiranya kuantitatif, sekiranya persamaan kimia yang kuantitatif, kita mesti ada pengiraan. Maksudnya, you must give me a question lah. Okay, ada bilangan mol, berapakah bilangan mol, berapakah apa yang kamu nak cari. Okay, you must give me a question. So, can you ask me again, Arun? Okay. You give me an example, contoh soalan. Cikgu cuba jawab. Tapi tafsirkan kualitatif dan kuantitatif persamaan kimia. Okay, if like that, for example, magnesium dan oksigen menjadi magnesium oksida. Okay, so if we talk about quantitative, 2 mol magnesium bertindak balas dengan 1 mol oksigen menjadi 2 mol magnesium oksida. If we talk about qualitative, ialah atom magnesium bertindak balas dengan molekul oksigen menjadi sebatian ionik magnesium oksida. Okay, so biasanya tak tanyalah dalam SPM. 1 or 2 questions. Very rarely lah. Paling banyak, I think only 1 time keluar untuk soalan 1 markah. Okay, can I have a next question please? Okay. Salts from Form 4. Okay, so every week I talk about this. Okay, so I'll try and explain as much as possible. But last week we talked about how to identify salts already. Okay, never mind, I can try again. Okay, so do I have many more questions? Okay, I'll see how many questions I have. Then I see whether I have time to discuss this because it's a very, very long topic. Okay, and I've done it like every week. Don't worry, I will also do it again in the seminar and in the video-video yang cikgu sudah sediakan. We've already also explained very, very thoroughly. So sekarang untuk for me to explain one whole chapter, it might be a bit compressed. But if you have questions on salts, I can answer. But to explain a whole chapter, I don't think there's enough time. Okay, I'll try my best. Okay, can I see if I have another question? I'll see how many questions I have. If I have enough time, I'll come back to discuss this. If not, then please refer to the seminars and the videos because we have talked about this many, many times in those videos also. So there are more because it's a very long topic. About this now. All right. So, okay, so first thing you have to know is garam yang larut dan tak larut dalam air. So soluble and insoluble salts. Okay, so soluble salts and insoluble salts, you have to figure out who is soluble, who is insoluble. Okay, and the way to do that is you need to memorize. I'm so sorry, but this chapter is a lot of memorizing. You don't have to memorize everything. Okay, you don't have to memorize everything in the buku rujukan, but you have to memorize some things. So the first thing you need to know is there are 4 categories of salts. Okay, so nitrates, sulfates, chlorides, carbonates. Okay, and then you have, this is your anion. You have your cation. Okay, so any anion can combine with any cation to form a salt. For example, potassium nitrate, potassium sulfate, potassium chloride, potassium carbonate. Okay, and then sodium also same thing. Sodium nitrate, sodium sulfate, sodium chloride, sodium carbonate. Then calcium also same thing. Calcium nitrate, calcium sulfate, calcium chloride, calcium carbonate, and so on. All the way to ammonium nitrate, ammonium sulfate, ammonium chloride. Okay, so all the cations can combine with any of the anions to form salts. Okay, so that's the first thing. Now, the second thing is some of the salts are soluble, some of the salts are insoluble. Soluble in water means that when you take potassium nitrate, you put in water, it will split to become potassium ion and sodium ion. So you cannot see the solid anymore. But like silver chloride is insoluble. So you put it inside, it won't split. It will form a silver chloride at the bottom. Okay? So all nitrates are soluble. Okay, that means as long as there's a nitrate at the back, it is soluble. For example, potassium nitrate, sodium nitrate, calcium nitrate, magnesium nitrate, lead nitrate. Everything with a nitrate at the back is soluble. Okay, sulfate. All sulfates are soluble. Okay, sodium sulfate, potassium sulfate, magnesium sulfate, all soluble. However, except calcium sulfate, barium sulfate, lead sulfate. These three are insoluble. Okay, everybody else soluble. These three are insoluble. Okay, chlorides. All chlorides are soluble. Okay, except for silver chloride, lead chloride, and mercury chloride. But we hardly use this lah. Mercury chloride we hardly use, so it's not important. Okay, carbonate. All carbonates are insoluble. However, there are some that are soluble in water. For example, sodium carbonate, potassium carbonate. These three are soluble. Okay, so that's the first thing you have to memorize: solubility of salts. Okay, that's the first thing you have to remember, because if you can't remember this, you can't do anything. Okay, so I'll come back to this. Okay, I'll come back to this if we have more time. So we talk about solubility first. Okay, let me answer the next question first. Okay. Okay, so so this layer 1, all right? So we'll come back to this in a while. Okay, Arun is asking, sel Daniel, ke elektronegatifan, ke elektropositifan. Okay, ke elektronegatifan dan ke elektropositifan. Okay, ke elektronegatifan ialah kebolehan menerima elektron menjadi ion negatif. Semakin banyak dia suka jadi negatif, semakin elektronegatif. Contohnya fluorine, bromine, chlorine. Saiz dia, fluorine paling kecil, chlorine besar sikit, bromine paling besar. Untuk tiga-tiga ini, siapa paling reaktif? Fluorine. Sebab saiz dia paling kecil, paling senang untuk menerima elektron. Oleh itu, semuanya ada 7 valence elektron. Semuanya hendak menerima elektron. So, fluorine lebih elektronegatif. So, kini kita tulis keelektronegatifan bertambah. Sebab dia lebih suka menjadi ion negatif. Okey? Keelektropositifan terbalik sajalah. Kebolehan membebaskan elektron menjadi ion positif. Contohnya lithium, natrium, kalium. Saiz semakin besar. Semakin senang untuk bebas elektron sebab elektron yang paling luar lebih senang dibebaskan. So, arahnya ialah terbalik. Ke elektropositifan bertambah. Okay? Alright. Satu lagi ialah sel Daniell. Okay, sel Daniell. Okay, so we draw sel Daniell. Okay, sel Daniell hampir sama dengan sel ringkas. Bezanya ialah dia boleh dipisahkan dengan dua-dua larutan dipisahkan dengan dua bikar. Macam mana dia disambungkan? So, satu cara ialah guna salt bridge. Titian garam. Satu lagi ialah a porous pot. We can use a porous pot. Okay. Pasu berliang. Okay. So, di sini kita guna, macam mana nak buat titian garam? Kita guna kertas turas direndam dalam larutan garam. Okay, so contohnya magnesium, ini copper. So kita lihat balik siri kereaktifan. Okay, magnesium dengan copper. Siapa lebih reaktif ke atas? Siapa lebih senang bebas elektron? Dia lebih elektron positif. So ini ialah ke elektropositifan bertambah. So magnesium lebih elektropositif daripada copper. Okay. Magnesium lebih elektropositif, magnesium membebaskan elektron. Okay. Di sini, so sini kita guna magnesium larutan aqueous. Okay. So elektron bergerak daripada magnesium ke cuprum. Di sini ion-ion cuprum di dalam larutan menerima elektron. Okay, so ini adalah sel Daniell. Yang lebih elektropositif akan bebas elektron. Okay, ni lebih elektropositif. Okay, untuk elektron negatif kita tak guna sel Daniell. Kita guna contohnya larutan kalium iodida dengan air klorin. Siapa lebih elektronegatif? Klorin lebih elektronegatif berbanding dengan iodin. Dalam kalium iodida sekarang ialah ion kalium, ion iodida. So klorin menerima elektron menjadi klorida. Iodida membebaskan elektron. Mengapa klorin boleh terima elektron? Sebab klorin lebih elektronegatif. Okay? So itu bezanya elektronegatif untuk bukan logam, elektropositif untuk logam. Okay? Kan? Can I have a next question? Ada soalan lagi? Oh, okay. Esther. Okay, kejap ah. Alright. Okay, cikgu boleh bincang tentang Esther. Okay. So Esther buat daripada okay. So ester is made from alcohols and carboxylic acid. Okay, but what we do is we always write carboxylic acid in front, okay, and alcohol behind. Why? Easier to write equation. So we switch it a bit, okay. Carboxylic acid alcohol we write behind. Alright, now example of carboxylic acid. Propanoic acid C2H5 COOH. Okay, alcohol example methanol CH3OH. Okay, so what you do is you take these two, propanoic acid and methanol, you put inside a flask together with sulfuric acid, pekat, concentrated sulfuric acid, then you heat it up. But you need to do reflux. Reflux means here you got a condenser. So the mixture, propanoic acid and methanol, you boil, evaporate, come back down, evaporate, come back down until it forms an ester. Okay, so how do you write the equation about ester? This is the reason why we have the acid in front. Start here. Okay, so C2H5COOH. We do that first. We don't put the H, we just start with CO. Then we do methanol. That's it. That's your ester. Okay? C2H5 COO, then CH3. Okay, so this is the ester. That's how you draw it. Okay, how do you name it? Name is different. Name, you put the alcohol name in front. So it's called a methyl because it came from methanol and the carboxylic at the back. Propanoic acid gives you, so it's called methyl propanoate, two separate words. Okay, so how do I write the equation? So methyl propanoate, you start with propanoic acid, methanol. So the equation is reversible like that. So you have to write here concentrated sulfuric acid. Okay, so that's how you write about ester. Okay, can you understand? So basically it's just the same thing lah. Okay. Cikgu boleh terangkan maksud elektrolit. Elektrolit is larutan yang boleh mengalirkan arus elektrik. Untuk elektrolisis, okay, your electrolyte is the one inside the beaker. So apa-apa larutan aqueous atau leburan yang boleh mengalirkan arus elektrik. Contohnya aqueous natrium chlorida, larutan aqueous coprum 2 sulfat, atau leburan you can put leburan PbBr2. Asalkan dia boleh mengalirkan arus elektrik, dia ialah elektrolit. Okay? Can I have another question? Okay, so wow, it's a long question. Solid mothballs melt when heated in water bath. Okay. Based on diagram 7.2, describe the curve from region P to Q and then R to S. Oh, okay. Okay, so solid mothballs. So you have to understand solid, So P to Q, they are solid. Okay, 60 degrees Celsius and then 80 degrees Celsius, and then you heat it up to 90. And then after that Q to R, and then R to S. So you're supposed to talk about, so here they are all solid. Okay, here they're all solid. So you're supposed to talk about P to Q, and then R to S. R to S, they're all liquid. Okay, so you're supposed to talk about state of matter. So this kind of question actually quite fun. It's 6 marks, right? Okay, so state of matter, right? So P to Q, R to S. So here you just have to write solid, here you write liquid, and tada, you got 2 marks already. Okay, so first one was state of matter. Okay, second one is movement. So solid is in its fixed position and they only vibrate. Okay, liquid, they slide over each other freely. And then diagram. Okay, so solid, you have to remember, okay, liquid is the one, is where students always make a mistake. Liquids are not like that. No, that one called gas, okay? So liquids are like this. They're just not in order anymore. They might have place between them, but it's very little. Okay? So, tada, 6 marks. That's it. Yeah. Can I have a next question? Okay. All right. Wow, that's a long question. Hold on. Okay, so oh no. Okay. So diagram 8.3 shows the reaction of solid white W and the reactions that happen to W. So W is a solid and it's white. So because it's white, it's not a transition metal. Okay, it's not a transition metal. You add nitric acid, it becomes a colorless solution, the Y. Okay, and it also releases gas V and water. Okay, so straight away you know lah, what releases salt and acid releases, what salt with acid releases gas and water? So it's carbonate lah. So this has to be a carbonate. Okay, because carbonate and acid is salt, carbon dioxide and water. So you already know that W is a carbonate. Okay, and then you heat it up. You heat up this carbonate. It breaks apart to form. Okay, this is simple. Yellow when hot. So carbonate becomes an oxide. Whatever you heat up, it becomes an oxide. So something carbonate becomes something oxide. So Z is something oxide. Okay, and this oxide also releases gas V. So again, gas V is carbon dioxide lah. Okay, so yellow when hot and white when cold. There's only one thing in the world that you learn that is yellow when hot and white when it's cold is zinc oxide. Okay, because there's only two things that you learn that change color when hot and cold, which is lead oxide and zinc oxide. These are the only two things you ever learn that have different color when they are hot and cold. Okay, zinc oxide when it's cold is white, when it's hot is yellow. Lead oxide when it's cold is yellow, when it's hot it's brown. Got it? So now I already know, because it's yellow and white, it is gas, it is a zinc oxide. So if this one is zinc oxide, that means this one was zinc carbonate lah. And then this one is zinc nitrate lah. Okay, so identify V, W, Y, and Z. So V is carbon dioxide gas. W, where's my W? W is your solid W. So because when you heat it up, it becomes zinc oxide. So the original was zinc carbonate. Okay, and then Y, where's Y? Y is the solution. Y is zinc nitrate solution, and then Z is zinc oxide. Okay. All right. Describe a chemical test to verify the cation and anion in solution Y. Okay. Again, same question. So, okay, you have to memorize. Okay. What I urge you to do is, untuk ingat ujian kimia, sila pergi video SPM Flix untuk lihat balik yang cikgu pernah ajar semua untuk garam. So we have a lot of videos untuk macam mana membentuk garam, macam mana analisis garam. Okay, can I have the question again? Can I have the question, please? I wanted to do part B, is how to identify. My screen is blank. Okay, thank you. All right, so how to identify. So the second part of the question is how to identify the cation and anion in solution Y. Okay, so how to identify. So zinc nitrate solution, aqueous. Got zinc ion, got nitrate ion. So nitrate ion, you have to remember, is called a brown ring test. Okay, so in a brown ring test, you will see a brown ring. Okay, so nitrate has no insoluble salt, so you have to use a brown ring test. So in a brown ring test, you add diluted sulfuric acid, then you add iron 2 sulfate solution, then you add concentrated sulfuric acid. Okay, then guess what you see? You see a brown ring. Okay, for zinc, the easiest one is first you add aqueous ammonia, a few drops. Okay, it will form a white precipitate. Then you add excess, it will dissolve. Okay, yeah. Can I have a next question? A student carried out an experiment to determine the heat of precipitation of zinc carbonate. Okay, so you need to memorize first that zinc carbonate is an insoluble salt. Okay, so these kind of questions, right, is 10 marks. So you don't need to get panic just because it's 10 marks, all right? It's not that hard to do. Okay, so you break it down first, 10 marks. They want you to do reactants, procedure, and chemical equation. Okay, so you want to do heat of precipitation to form zinc carbonate. So you need to know that zinc carbonate is insoluble. So to make an insoluble salt, you need a soluble salt, with sodium carbonate. Okay, it will form zinc carbonate and sodium nitrate. Okay, so your equation is done. Okay, now before you do the reactants, so your reactants, you just write it down in words lah. Zinc nitrate solution and sodium carbonate solution. Okay, so that's also done. Now your procedure, before you do a procedure, you must know how it looks like. You don't know how it looks like, you cannot do anything. So you have to know that you have to have 25 centimeter cube of zinc nitrate solution. Okay, and then just put in a logical concentration. Okay, you pour it into another solution, which is, oh sorry, don't use 25. I think 25 is a bit too much. Let's just use 20 lah. Okay. Okay, now, first of all, before you do the experiment, you need to measure the temperature of both solutions. Okay, you need to measure the temperature, initial temperature of both solutions, right? And then you must say you prepare this volume, this concentration, this volume, this concentration. Okay, and then you just take a thermometer and then you stir, and then you measure what is the increase in volume, increase in temperature, sorry. All right, now, obviously, you cannot just put it in a beaker, so you have to say use a polystyrene or a plastic cup. Okay, and then you calculate heat of precipitation is the heat release over the amount of moles. That's your heat of precipitation. All right, so how do you write it? So you say, in a beaker using a measuring cylinder, measure 20 centimeter cube of zinc nitrate, 0.1 mole per decimeter cube. Measure the initial temperature. In another, using another measuring cylinder, measure 20 centimeter cube of sodium carbonate, 0.1 mole per decimeter cube. Pour it into a plastic cup. Pour zinc nitrate carefully into sodium carbonate and stir using the temperature. Note down the highest temperature reached. That's it. That's all you need to do for this experiment. Okay? Can I have a next question? Pengekstrakan ferrum dalam relau bagas. Okay, this one is not really in your syllabus, but I can teach you a bit. Okay, so this is basically blast furnace. Okay, pengekstrakan ferrum. So it's like this. Kita letakkan ferrum oksida. Okay. Dan banyak karbon. Okay, kita panaskan. Okay, apa berlaku ialah ini semua solid. Okay, the good news is dalam 20 tahun tak pernah keluar dalam SPM. So I don't think you're that unlucky lah. Tapi it's good to know. Okay, so kita panaskan udara panas. Okay, udara panas melalui ini. Okay, karbon akan membakar dengan oksigen. Okay, menjadi karbon dioksida. Ini jadi lagi panas. Karbon dioksida akan bertindak balas dengan lagi banyak karbon, arang daripada arang, menjadi karbon monoksida. Okey. Karbon monoksida ini akan mencuri oksigen, ferrum 3 oksida menjadi ferrum dan karbon dioksida. Okey. Alright, that's it. Ada kala karbon akan terus bertindak balas dengan ferrum 3 oksida menjadi ferrum dan karbon dioksida. Konsep ini ialah karbon lebih reaktif daripada ferrum. Okay? I think we have time for 1 or 2 more questions. Do I have another question? No more questions. Okay. So, let's go back to. I hope I answered your question, Arun. Okay, so relau bagas, that's it lah. That's how blast furnace. This is how you heat it up. Okay, so there's also a lot of silicon inside here, a lot of sand. The sand is silicon dioxide. Okay, so this sand will react with calcium carbonate that we put in to form. The calcium carbonate becomes calcium oxide. Then it becomes calcium silicate. Okay, so that's how you get rid of the sand. Alright. Okay, let's look back at what we were talking about just now, the salts. Okay, so you really need to remember the solubility. Who is soluble, who is insoluble. Okay? Right, so after you know the solubility, then you are able to know how to prepare different kinds of salts. Because salts that are soluble are prepared differently from salts that are insoluble. Okay? So for example, soluble salts, we have 2 groups. Potassium, sodium, ammonium salt, and other soluble salts. Okay? As long as they are asking you to make a salt that has potassium, sodium, ammonium, okay, you can use titration. Alright, meaning guna pentitratan. Okay, di mana kita guna acid dan alkali. Alright, for any other soluble salts, you cannot do this. So if the question asks you to make potassium nitrate, sodium chloride, ammonium sulfate, any salts that have potassium, sodium, ammonium, you use this method, titration. Okay? Other soluble salts you use, for example, you want to make magnesium sulfate, you either use acid with magnesium, or acid with magnesium oxide, or acid with magnesium carbonate. Okay? Alright, now let's run through all that we have learned today. I think today we had so many questions. Okay, very happy that ada banyak soalan sebab maksudnya pelajar-pelajar sudah sedang buat banyak-banyak ulang kaji. Okay, so let's see what are all the questions that you have been asking. So we started out with okay, hold on. Okay, so we started out with questions on metal and non-metal. Okay, we talked about endothermic and exothermic. We talked about sublimation, pemewajapan. We talked about, please make sure you practice all your empirical formula, okay? Sebatian karbon, kita ada buat rumusan tentang sebatian karbon. Again, ada banyak video tentang sebatian karbon dalam SPM Flex, okay? Okay, we talked about sebatian ionic, macam mana nak membentuk sebatian ionic, and bezanya saiz antara atom-atom dalam jadual berkala. Okay. Now we also talked, I think, a few times on how to prepare esters. All right. Okay. So remember, to prepare an ester, we use carboxylic acid and alcohol, and how to write the equation. Okay. Alright, so these are examples that we did today on how to make esters. Alright, one more thing important, redox, always remember who releases electron, who receives electron. You need to remember at least 2 oxidizing agents and reducing agents. So reducing agents are the ones that undergo oxidation. Oxidizing agents are the ones that undergo reduction. So remember your potassium manganate, remember your potassium dichromate. Okay, then we talked about how to do redox reactions using electron transfer. Okay, so there are many ways to do electron transfer. One is you just use a test tube. One is you use a U-tube. Okay, so this is making electricity using different solutions. Electron transfer can also happen during electrolysis. Electron transfer can also happen during simple cell. Okay. Okay. Endothermic and exothermic. Most of the time, all your calculations are exothermic. Endothermic question is only ask you what kind of reaction is this? Is it endothermic? Because the temperature goes down. So we talked about the difference between siri elektrokimia dan siri kereaktifan. Dia ialah dua siri yang berbeza. Okey, tapi lebih kurang sama. Bezanya ialah kedudukan karbon dan hidrogen di dalam siri dia. Okey. Okey. Beza keelektronegatifan dan keelektropositifan. Alright, so keelektropositifan ialah logam sahaja. Okey, logam sahaja. Keelektronegatifan ialah boleh menerima elektron, iaitu bukan logam. Okey, so logam melepaskan elektron ialah elektropositif, bukan logam menerima elektron ialah elektronegatif. So ini contoh. Okey, kita buat 2 kali hari ini. Macam mana nak menentukan bagaimana nak membentuk ester menggunakan alkohol dan carboxylic acid. Okey, apakah itu elektrolit? Elektrolit ialah apa sahaja larutan atau leburan yang boleh mengkonduksikan atau mengalirkan arus elektrik. Alright. Cara untuk menentukan kehadiran sesuatu ion, ini pelajar mesti pergi hafal lah. Kamu mesti belajar balik, imbas balik semua ujian-ujian dia. Bukannya banyak, dalam 2-3 video saja. So ada masa pergi tengok dalam SPM Flix. 2-3 video saja untuk macam mana menguji cation, macam mana nak menguji anion. Okey? Alright. Kemudian kita buat 2-3 soalan essay tadi untuk macam mana. Alright, so I hope that you enjoyed your session today. Terima kasih kepada semua yang menonton hari ini. Cikgu harap anda semua banyak mendapat manfaat daripada sesi ini. Jangan lupa layari spmflix.com untuk menonton video pembelajaran. Okey, kamu boleh menonton video-video yang dalam bab-bab SPM dan Form 4 dan Form 5. Kamu juga boleh lihat sesi tanya cikgu yang lain dan juga rakaman video yang sesi-sesi lepas. Jangan lupa esok tanya cikgu akan kembali untuk subjek perakaunan dan biologi. Pendaftaran untuk seminar 2019 sudah dibuka untuk SPM. Pelajar yang berminat bolehlah melayari www.spmseminar.com untuk daftar dan mendapatkan jadual. Thank you. Terima kasih. I see you soon. Bye-bye.